didn't get quite finished the slides last time, so I'm going to try to recycle.
Is this camera gonna be here every day now?
Yes,
Why?
because there's a student you can't do.
Oh,
Is it trouble with that?
it's weird. It's weird. I'm sorry.
You can be preserved forever now on the Your numerous comments will. No?
Maybe I'm not getting it.
All right, so yeah, we're gonna be finishing out this stuff on this set of slides. Unfortunately, there's a few anachronisms, so I'll try to point them down as we hit them. The first one is that yeah. Actually, maybe that's not so bad. We could look at the wiki entries so far, but you know, this is the startup stuff from last time. So I do still need a little roll call. That's not wrong. And then the announcement about next Monday is still correct. So that's good. We're not going to look at it. I think I don't want to look through the wiki entries so far just now. Okay, so Eric, Crystal Basic, Melissa Young, Tom Brown, Robert Brown. Francesca, Brandon Eager, Anthony Espinosa, Allison Fromm, Allison, you here? Tom Lee, Erica Jones, Joe Lombardi. This where he was right there. I just talked to him. The camera made him run away. Nick Borson. Yeah. Kiera Laughlin. Jillian Massey. Danielle Mitchell. Robert Blues. Samantha Price. Rachel Rattler. Maria Sanchez. And Amanda Bell. Actually, there is an announcement, a startup announcement that I should have had on today's slides that's not there because these are the last batch of slides. Has anybody heard of the Putnam seminar? I would like to really encourage folks in this class, I think, because you're at the point where you're getting pretty mature in your mathematical abilities, to check it out. It's basically every Friday we have a seminar problem session. I don't know what to quite call it, but basically there's free pizza and we work on really, really hard problems to see if we can solve them. The idea being to get ready for this contest that's held the first Saturday in December. Now, if you come to the seminar, you can take the test. You can not come to the seminar and take the test, or you could come to the seminar and not take the test. I think there's probably another possibility. Yeah, don't come and don't. But yeah.
If we can't make those meetings, is there a way we could get some of the problems that you work on in the seminars?
Absolutely, yeah, I could do that for you. So Friday at 1 o'clock is when the seminar is.
Yeah.
You gotta be out there. Yeah.
So the seminar is Friday at 1 o'clock?
At 1 o'clock, 1 to 3.
Is it like the math club or?
It's usually the same characters as the math club, but it's not officially a math club activity. Although it's mainly run by Dr. Dinker, who is also the math club advisor. The Putnam exam is a very strange phenomenon. It's a 6 problems in the morning session, 6 problems in the afternoon session. Each problem is worth 10 points. So there's a possibility of 120 points. It's an all-day thing on Saturday. When I took it as an undergrad, I got a 14. And you're like, feeling pretty depressed when you find out you got a 14. My professors were giving me high fives in the hallway. They were so excited that I got a 14. Since then, we've had students here at Southern get 20s, which is amazing. The median score on this test is usually 0. That is, half the people get nothing. All right, so we're talking seriously hard problems, which you're not likely to do well on without some coaching. But trust me, it's possible to do a little bit of coaching and learn certain standard techniques for getting at these things and do well. I mean, doing well means getting a non-zero score, honestly, on this thing. Anyway, the seminar itself, I think, is a lot of fun. Come on, you've been to it a few times, right? Who else has been to it? Well, we usually have a pretty good time. You did go. I know you were there once at least. Anyway. All right.
Does the seminar prepare you for the test?
So, there's nothing on earth that can prepare you for this test. I swear to God, it's brutally hard. So I was a non-traditional student. I probably was 28 years old when I took the test. So after a whole day Saturday doing this thing, I went out with my friends drinking. I'm not proud of this, but somebody bought me a drink when they heard that I'd done this crazy thing. So they were like, "Here, celebrate." Okay, give me a drink. And I'm holding this thing, talking to people, and all of a sudden it just slips out of my hand, crashes to the floor, breaks, and And we're like, well, that's weird. Joe never drops his drinks, but somebody they gave me a new one, and then I dropped that one. I was like, okay, it is time to go home. My neurons literally were no longer working. I worked my brain so hard that I couldn't hold on to something. That was weird. Yeah. So, what else could I say about the Putnam? It's ridiculously hard. It is. I think it's a fun experience, even though it's ridiculously hard. If you sort of resign yourself to the idea that getting single-digit scores is still a good thing, then you can relax and enjoy it. The problems are really out of left field. I mean, you're kind of used to finding the area under this curve, and Putnam problems aren't like that. They're just often bizarre. I mean, you're like, how could I possibly attack this? But then you start thinking and noodling, and you try things, and so a lot of times solutions come out. So I'd like to really encourage everybody to check it out, see if they enjoy the, at least come to the seminar, because that's more of a social thing than anything. All right, so that's startup stuff. We talked about Babylonians and how to convert between different bases ad nauseum last time, but we didn't get to this slide. So I want to talk about this trigonometry controversy. There was an article last fall in the New York Times highlighting this research that had been done. The scientists, the mathematicians, were from Australia who did this. And they looked at that tablet that I keep showing at the beginning of the slide section, which is called Plimpton 322. Plimpton is a guy who just collected antiquities. Okay, so this was the 322nd thing in his giant collection of weird antique items, mostly out of Mesopotamia, but other things as well. So the question is, did these ancient Babylonians have some notion of trigonometry? There's some reasons to think they would like that. And it is because of where they lived. The Tigris and Euphrates rivers flood and just destroy the boundaries between people's fields. That was the problem. So you would have your fields laid out. These are mine. Those are yours. And then a flood comes and you can't figure out whose is what anymore. So if you had to put the sort of descriptions, the map of the fields all laid out, you could reestablish those boundaries. So that would be useful for them to know some trigonometry, to do that laying out of the boundaries between their different properties. But did they? Or did they just throw big rocks at the intersections to mark off the spots? So these guys in Australia claim there's strong evidence to say that this Plimpton 322 tablet actually means they were beginning to think about trigonometry. Probably not in the sense that we think about it. I mean, they wouldn't have had the sine and cosine functions, but they start thinking about triangles and their properties. What is this evidence? It turns out, and there's no controversy about this, if you look at those cuneiform writings on the tablet, and they're arranged in columns of numbers. There's a X, Y, and a Z column. Actually, there's a fourth column that is just literally numeration. Here's the first one, here's the second one, here's the third one. But then the X, Y, and Z columns turn out to satisfy X squared plus Y squared equals Z squared. So those are integer numbers, yet they satisfy the Pythagorean theorem. So something about triangles, no? What does that say trigonometry? Just because they knew Pythagorean triangles, Pythagorean triples, rather, does that mean they knew anything about trigonometry? The Australian guy said, look at the actual triangles involved here and see what the angles on them are. And there's where it's surprising. They're like 1 degree increments. And so it's a list of triangles with integer sides at 1 degree increments of one of the angles. And I think there's 15 of them, so it's 15 degrees of different triangles. They're not perfect. They're not exactly 1 degree increments. There's some off. But, you can well imagine they had to work really hard to find things that were close to the right angles, and they got as close as they could because it was Babylonian. They couldn't do it perfect yet. They didn't have computers. They had guys with sticks. All right, so our next paper, our next assignment is going to be to say something about this Babylonian trigonometry controversy. Just a one-page paper again. Try to have a paragraph saying something about arguments on both sides, and then a concluding paragraph about what you think. I would say Google is your friend. Yes. You do not need to cite anything for this paper yet. So one page means just one page, no citations or anything. We will be doing a session with math and STEM librarian next week, and then we're going to talk. From then on, we'll have citations. For now, just write stuff, and you don't have to. In other words, I'm authorizing you to plagiarize. If you want to find something on Google, rephrase it, that'll be fine. What else? This is going to be written in a system that's called LaTeX. Some people say LaTeX. It looks like the substance that, what is it called? Some people are allergic to. The rubber gloves are often made out of latex. It's spelled that way, but it's not that word. It's LaTeX. Anyway, TeX was a system written by, I should probably have written a slide about TeX and LaTeX. This guy is like a god to me, Donald Knuth, who wrote The Art of Computer Programming. If you want to become a good computer programmer, get The Art of Computer Programming by Donald Knuth. It's amazing. So he wrote TeX as an example of how to do what he called literate programming, meaning he wrote the program and he wrote its documentation at the same time. And that way, well, it's a style that allows you to in many people's opinions, do better coding. Because this guy is sort of godlike in his computer ability, but also this idea of doing literate programming, TeX is recognized throughout the world as one of the most bug-free programs ever devised. It seems to, at this point it's 25, 30 years old, but it just nobody can find a bug in it. It's just that good. LaTeX is built on top of that, and it is a system for typesetting math. That's the main reason you need to know this stuff is because even outside of using LaTeX, the math shorthand that people use all the time for mathy stuff is this LaTeX code. So I wanted to show you some examples of what LaTeX code might look like. Suppose I wanted to create something like this. The sum from I equals 0 to 100 of I is equal to, God, what is that? Should have gone from 1 to 100, sorry. And it's 5,050. If I wanted that to appear on the page, so, okay, let's say this is what's on your page or on your screen, you have to write code that encodes that stuff. And so it would look something like this. Actually, first there'd be a $sign to let it know that you're doing math. And then the sigma here is created by writing /sum. I equals 1 to 100 is created by saying there's a subscript that has I equals 1 to I equals 1 in it, and then there's a superscript that has 100 in it. Oops, braces around the things. And then, so we'll have the sum from I equals 1 to 100 of I, and then equals 5,050. This part is all good, all the same, right? But that's the way you'll have to write your stuff. You'll write it in this arcane code, and then you'll push a button that says go, and it'll process it, and you'll get a PDF that looks like that. So that's one example. You want something easier, I bet. Like, if we're talking about Pythagorean triples, you need to have something that rendered as x squared plus y squared equals z squared. I actually already showed you this symbol for putting an exponent in. Did you see it in here in this one? It's the, okay. So if you wanted to get that to appear on the screen in your text, you write $x to the 2 plus y to the 2 equals z. Math stuff, when you're doing this LaTeX business, it has to start with $1 and end with $1. The most common error is to forget to end the $. And it still thinks you're in math mode, and it's trying to interpret stuff that you're actually just writing words as math, and it gets very confusing. So watch out for that. That's one of the things to learn. Anyway, our class on Monday is going to be mostly about getting you started on using LaTeX. So, yeah, let's get this writing in cuneiform project going. We're going to have to rearrange the tables, and there's 21 of us if everybody's here. Is everybody here? But they are. So that means 5 groups of size 4. I have 5 marker things, so yeah, move around.
When is our next paper due?
It is, I didn't say yet, but I'm going to.
Next year.
Next year, no. 14th.
Friday.
Move.
You guys can come over here.
Just move around, yeah, that's good. You have a nice big table to work with there. You can take the other chairs if you want. Groups of 4, please.
They use like this in my phone.
What?
Okay. I'm putting got the 300 papers.
Yeah, so I'm doing like 2 classes for 2
So what's the deal here? I want you to come up with a large number. Yeah. Each of you is going to take this. Wait a minute. Oh, we're going to have enough for
I still don't believe that you're a math major, like, because we had school help together, and I was like, oh yeah.
Busy.
I didn't know that.
Join these guys.
I am. I'm trying to get seltzer water. Trying to get a seltzer water out.
It's salsa.
I don't know, I'm trying to get alcohol out.
I shouldn't have never told that story, should I?
What story?
The one about the puzzle spilling my drink?
What?
Huh? Were you asleep when I was just talking to you?
I literally don't remember anything from Calculus 1. Like, at all.
That's the nastiest stick there is, sorry. All right. So,
Oh my gosh, and I had one out this whole time. After all of that. Okay, I'm not moving this desk. I'll knock your camera over.
okay, so what are we doing? Calculate how old you are in days.
What?
How many days old are you?
20.
20 years. How many days?
I don't know. Whatever 20 times 365,
How old are you in days?
and then add another day because we had.
We have to go like that.
I don't care. I mean, really, this is about writing a Babylonian number, so yeah. I mean, you can make every month have 30 days, no leap years.
Well, isn't it 365 times 3? Yeah.
365 times your age, plus if you were born in December, maybe you should count a few months extra. But you're going to need to convert that number to
Yeah,
sexagesimal
we have
and write it in Babylonian form. And write it in
If it's in the folder, is it July, August, or September? It might just be a section of.
Oh, wait, I haven't given out enough Play-Doh yet, have I?
PDF,
Who still needs Play-Doh?
all in one.
Did he give us this stick?
Yeah, I did this.
Yeah, I do.
Do you have Play-Doh?
Oh, yeah.
So maybe flat.
Let's do it on the middle.
Is it enough for 2
I stick calculation.
I'm gonna throw you another.
That's something yeah. So are we each doing our own?
So everybody, and once you get your date, once you get your age figured out and write it in.
Early childhood education is on the
I didn't know that.
So why do they have to have
No,
a
it smells terrible.
Oh, I don't want to.
I have a radar at the E.
Poison the stuff.
My mom had childproof things. Wait, really? I have a child. No, she's not. Yeah, good job. Tell her push So I'm a child. Same thing. I had
Making any progress, guys? You know how old you are now?
Why we're using Play-Doh.
Can you convert it to base? Or what was it last time, you want to divide it by 60, figure out the remainder, that'll give you units place. And then
days. I was gonna say, we're doing our 80 place 60.
No.
It's just gonna be like 20. It's gonna be like 20, whatever.
to work out how old you are in days.
Yes.
No, wait, I'm gonna Google. Okay, Google, how old am I in days? Hold on, when were you born?
I can find phone. Wait, May 3rd.
You were 65. So you don't feel like you really want to wake up?
So in days?
Probably.
It is in days. What is that?
Is there enough for everybody to do their own?
That's mine, because that was like their face.
There's a website.
That's a really nice flat.
You're gonna break the desk. Don't have it.
Then you're gonna make the edges very smooth.
Well, I got my base 60 inch.
And then we have to take this out and bake it in the sun.
So this is our
Well, there's no sun.
All right, they won't just build a fire.
7,200.
You should bring the cake program.
So it's 45 inch
I have my remainder.
by
So divide it by your, so your 31 on top, you divide that by 60.
Divide the 31 by 6.
So you're 7,000 years old?
Well, you don't want to do it on the same thing.
Well, I feel like a kid, but wow.
So like mine, you divide it by 60, that's my remainder. And then this is what I divide by 60, and that's my remainder. And then I take this, and divide that by 60, so you take 0,
Oh, that's right, and
that's
then
your
you
remainder,
take
and that goes in that order.
Okay, alright.
It helps that I did this in the summer.
Really?
When's your birthday?
I did like a little birthday.
Alright, mine's super. Wait, I'm
Working it out really exact.
We will see because yesterday was my birthday, so I had just like one day, so we will see.
Would you like some Play-Doh?
For a present for you.
When you get to the number
I understand, I probably did things as soon as I said.
Okay, I'm just
I had,
So, now can you turn it into base?
that third foundation test was on my birthday. That's why I was like, we shouldn't have.
Oh wait, yeah, I remember yours.
So remember the repeated division? First divide by 60 and find out what the remainder is, that'll be your units. Okay, so how old are you?
It's my tablet.
Okay.
But that's clear.
So,
19?
all right.
30.
Elaborate.
Yeah, we can wait that.
Okay, so 23 times 3.
Oh, okay, I was thinking it's 44, I'm getting nervous.
And your birthday was 38 days ago?
Alright, now that I've
Okay, so he doesn't have a living
So, I don't understand.
See, that one yours is easy.
Yeah, I feel like I should.
It's a no.
You have to divide that 60 and then the remainder is the.
How many digits? So how many times is it evenly divided?
I have 3. Well,
Most people should have three.
it's like you divide it in.
Because if you
and then
had-
the
4 over
remainder
60.
is
How,
the
what's the
last
smallest
number
quarter
of the
number?
number that you're finding. And then once you can't divide
If they had 40?
that's your number.
Oh, I thought you
So
meant like the full
ask
remainder.
yourself in base 10, what's the smallest quarter you go?
Wait, so you do, like I did,
Base 10, right?
my days
Yeah,
divided
15
from
comes
fractions
from,
to the
so like the first step is divided by 60.
No, 9,990 is big enough.
I tried math.
When you first bump up to the 40.
Don't you?
That's
We know
the
math.
same process. You're gonna be a 1 and this is 3 zeros. The smallest is the number that there's
15 over
Wait,
60.
you wait, did you get this? Because I had my
that number was.
answers go back.
One,
Oh.
62 spot.
The next digit,
Wait, you really want to leave this fully painted?
Well, it's 60 times 30.
Why doesn't it rip nice?
Wait, what do I do with it? It's whole job, I got like 100.
I don't even care. Who cares?
Well, you're gonna say this too.
What year are you guys? What class are you taking?
So that's like,
I need a copy of it.
How many days old is Joey?
the first one is.
7,132.
Doesn't that seem like a lot when you hear that one? 7,000 days, doesn't seem like that.
yeah,
So what about turning that to base 60?
What my
Can
first
you-
one is-
can you all turn this over to base 60?
it's that number.
That's 60.
Then it's base 10.
I think so.
You're starting it, divide by 60.
What do I do with this?
So, no, the .9166, that's the remainder written over the divisor. That's something over 60. You want to figure out what that something is? So just, if you take away the extra part,
Tens and,
So what should we have on the
yes. You'll just have to adjust the decimal, and then times that by 60 to find out what fraction of 60 that thing is.
And that's your, like, gonna be.
That's your remainder, yeah, and so that, yeah, exactly, that's your one.
Zero, your remainder.
So,
Oh, I think I subtract, I subtracted it. Yeah, and then 2.
Yeah, I just the number you just got.
Exactly, then you look at the next quotient, that's what the remainder is, so you divide that by 60.
That's what you do right here. This number,
yeah, no, that's right.
2 times.
Did I do it right? Can you,
You should get a,
So now we
you should get a cell phone.
Why is
So I
that?
take the decimal out.
Why does my really go something?
but then you.
The ones down here would
So, that's my number.
It's actually called home.
Wait, why is that? Does that say 2 divides next to 60?
Yeah,
That's like 2.
What is it, your log?
So I divided this is my base set. So I divided my 13,000 plus 2 and I got 195.
Well, I also added 90 days.
So what I do to make it easier, I got myself.
It's gonna be
If you do, and you say divided by 32 times 6, you're at 2,000.
What's your guys'
Yeah, because I got.
And then 60 times 13,000.
So,
Yeah, so then I times that by 60 and my next number.
Everything.
So I did 7 divided by 60.
That's not right.
Yeah.
That's what I.
Yeah, that's what I
I literally just did. Wait.
But we all.
Wait, why is yours saying
You're like, because if you remainder, it's like one digit. You're writing it weird. So when you don't.
Oh, wait.
Yeah, and that's 13,000.
Yeah. No, I just.
That's right, that's in the right thing. Are you like 20? Okay.
I got two.
It's gonna be your last.
So I'll try to write it in
So like, see,
Play-Doh.
this is my remainder, that's my last. And then you take, you're gonna have to type this here.
Everybody has to do zero the last one. Now yours is harder than
No,
because you'll see a two.
It's 65
clubs. I know you get extra.
If that's your, divide by 6 times 0.
And that's the middle. Separate. So that one is where it's like.
Yeah, and then this is.
So you don't know, you have.
Zero hadn't gotten invented. And it
No,
didn't. I mean,
that
the
makes
Greeks went all the way through their one. There's actually a whole book called
And then you take the place, it's gonna be.
History of
This is my last remainder, like
the
my,
history of zero.
I took 121 divided by 60.
Yeah, Amanda, I gotta write that.
You only got to
Zero, and then you subtract zero, so you're gonna.
So try, you remember how to convert this one?
I was like, I thought I did it first by
Yeah,
hand.
so now that's
Yeah.
fine. So I'm gonna make sure right now, so you're gonna be 52.
Yeah, I've only done it since that one class where the guys are.
And now you might do that by 2.
Like,
And you times that by 60, and now you
Oh, no, See, it's,
Oh, so what wrong?
this way.
So what I wrote everything.
Yeah, because you're going right
So
through.
at the end of this one, you have 19 is the quotient, 55 is the remainder. Then you did 16, more 19 goes in.
But the first remainder goes all into the right.
Oh, okay.
So you are right,
And
but I
then the
thought
remainder is
that.
59. That's the second digit.
I get, yes.
Now 16
We're on the
long.
same page. It doesn't sound like we're like definitely on the same page.
These are
It goes no times. Now we know we're done, unless the remainder is going to
two small ones and.
be 1.
Because you can't see
0 times 6 will be 0, and then subtract to get it. So all that's wrong is you don't.
I have two small ones, I'll put two.
Now check it with the
Well, the triangle's
what do you call it? The-
oh, it's actually already.
Yeah, it's already.
It's the square, right? Yeah, that one is in the hundreds place.
This is just 60 to
You
0.
gotta do like that.
Oh, yeah.
And this is, the 26 is 60 to the first. There we go.
That's your number, okay. So then, can you chisel that into the Play-Doh with your
I
stick?
think you,
Just have a stick there.
Yeah.
so like, two would be two small.
I'm just tired, but now I'm good.
Got a hand up. What's up, what's up?
Okay, so originally I just come out.
Really? Okay. So you've got a number there, that's the sort of thing that is in that range. Because they have no one for zero.
Wait, my last, so you did it, so what do I do?
So the next number is 2. And then you divide by
2, and then the next one is 2, 0.
So then it's.
So it's 6, 0. Wait, no.
My last remainder is like.
Except in the reverse order, right? 0, 26, 2.
So then it's 0. Yeah.
Oh, I see, you've written.
I just put, like if I wrote it. So this,
No, I kind of did my little last because I didn't have a lot of room, because you might need a longer thing if you're gonna do that.
I think you gotta do one or the other, like just.
Yeah.
Yeah. So after you divide it,
So when
you
you
then
go to
take the
regular
remainder
Play-Doh,
and
Yeah, like,
divide
see how
by.
mine,
you're gonna start with just 2 of the verticals, and then here's the vertical things. Then leave a little room, and then you'll have to write
because your
26.
number's so.
Oh, okay, that's what I like.
I'll also- I'll also write it.
So it would be 20 by making 2 of each, I think. Those kind of stuff. And then 6
So
of
then
one.
60 divided by 3.
The usual way was, right, just got the stick.
Like a 10. Oh, I do,
I should have stuck.
My number's still right.
No other words.
And then this usually be done on 2. Well, 3, they do kind of a textbook. I messed up your thing though, but that's your 26th in the middle.
Okay.
Oh, okay, you're trying to draw with that thing.
Spread it out.
Shove it into.
Here, once more.
How are we doing?
I'm pretty long.
1, 2, 3, 4, 5.
That's why we have 2 on.
Sorry, you had that. 19. Yeah, very cool. I see that. And then, so it was. So I guess they would have liked to see more space. Like, look at the club. Just.
I mean, honestly,
Yeah. You guys want to take pictures of your
Yeah, that's how you should write it.
page or something? By the way, those are upside down, the height and the tip. It's like, it's
Oh,
really a
wait,
long
I just
T.
figured out.
Oh, is it supposed to be strict?
Yeah.
Oh, so I did it wrong?
You did fine. Don't worry, but, I mean, the fine points about what you're
Yeah.
writing.
Yep.
Turning it back.
Oh, yeah.
I'm doing something.
If you were thinking of time, yeah.
And
But hours are fine, because hours are
Have you-
actually 4.
And those you take.
Yeah.
show that.
For the
Is there anything else
biggest portion, the answer is 4.
so, is it like just making
And I
it
just
like
say
this?
Well, that's the answer to this.
Oh, I do not like it.
The stuff in class is
Let's go further. Part of Samaria.
Awesome.
So what do you guys have to talk to?
So I think they had already divided the day into 24 hours, and then they wanted to divide it.
You guys,
I mean, like, I didn't think that's any.
I would
But that's, then everybody knows the score.
Like data.
This sounds
Oh, no,
like
no,
these
it's
two
not.
tests, they're like the final,
the months will be.
the average.
Are you gonna represent your age and race?
No, the median,
Oh, the median.
the average was below 20. Because people weren't even showing up for that. People got their tests and it'd be like 30, a 25, a 56, a 70. One time we had us do like one of the Taylor polynomials up to like a 9th power. And it was really hard to take. I was like, dude,
Like calc 2 was not, like it should not have been that great of a class. I
mean, that's
just
a
got
bit-
terrible
So you're
grades.
gonna try to make it 20?
I took one computer
I'll tell you.
Yeah, calc 3 was so easy, like, and I like did really well in that class. Like I understood everything from calc 2, whereas grades did not make it seem that
Totally bored. Did you get your,
Test if there's no.
did you work out?
these are
They put it away?
It's just all tests.
Yeah, we all were drawing.
Oh, okay. So that looks like, well, you don't have to. The point of that T thing on there is that it's sort of creates the bar as you go. Right? So you see
So I have,
that, you almost see that. I think they would do something like what y'all were doing. Just take the trace on the bar. And then
Find out.
we're trying to
Forget
get
what
what
she
she
Space. Not 55. These are your 10, so 5.
normally try to line up.
I just taught some
Distinguish it. So does everybody get somewhere?
Kind of like.
You know, you should be about one of these guys.
I don't know if it's the hard part, but he seems like no.
Are we all finished? Are we all got something else?
I haven't read it. Wow, it looks like I have a future in something now.
This Play-Doh matches my seconds.
It does!
That's the most exciting thing I have to say.
But how, like, closeness or separate? Imagine
You want a little piece of it, so that you see that as one unit, and then.
Like holding.
Well, I was on a giant hip, I have a giant hip.
Nothing happens.
I wish they sold them in the
Where's
store.
your other-
Yeah, but it's like half the it's a small
I like my,
don't want
rated.
I'm not gonna like anything that don't really do hard.
Right, this is the problem, is they would
I
run
used to love
My
friends who used to come all this like I was like honestly like
Oh, that must be-
I don't even know to where you guys speak.
I'm just trying to point out to you that with their system, this is very
I took a PQ with this guy at the scene, so it was awesome because he only took like minus one, which is that was nice. So I didn't do it.
Well, I took it this summer, I just.
Are you guys all linear then together?
No, I did it right.
Are you linear right now?
So what is this?
Oh, everybody else.
I love that.
You should, you have to take it next semester then, because you know what, because,
That would just normally be.
yeah, that's what you did, because
I
like,
had that
yeah.
on the same time as the class, so I was.
I mean, don't
That's what I thought.
You're gonna need to
I'm very proud, you guys would make great Babylonians.
or you're gonna have to over the summer. So technically need to take.
Maybe we should, get off of that and, return to that.
We'll give it 250, 3 and linear. That's not right.
You could have honestly shoved it in there too.
Okay, so yeah, last thing before we go today, because we're 5 minutes away. Can I get your attention back, please? I mentioned this, but there's some stuff in here that you'll need to do over the weekend. So the second paper will be written in the system called LaTeX. It is actually spelled like this with some letters capitalized and others not. That's just a thing. So we're going to use this thing called SAGE. Now, a couple of you have had it for classes before. I'm a big proponent of SAGE. But the SAGE computer algebra system is this free computer algebra system that I think is really neat. But in order to support this free software movement, they've created a company called CoCalc that lets you run SAGE for free out on the web. So you just go through to it via a web browser. And since they were doing that, they threw in a bunch of other stuff. And one of the other things they've done is add a LaTeX distribution. So you can be working on your LaTeX source code and the program that converts it to what should appear on the screen or what should appear in print is already there. And it's a pretty decent way to get at LaTeX for free. So I didn't want to have to, there are paid services you can use where you can download something to your machine. I thought the downloading process is a little tedious, a little bit, tends to go wrong. So I thought it'd be better if you just had this free web-based service to use. So that's what we're going to do. This also has the advantage that it's set up for like a classroom use thing. So I can have your guys' stuff get submitted back to me electronically. So I don't have to worry about any papers. So anyway, to get this happening, you have to go to CoCalc and make yourself a free account. There's options to pay for it. If you feel like supporting the free software movement, I would encourage you to pay for it, but you don't need to. The whole point of this was that it's free. I am going to pay for class access for the next 3 months, so that part will be taken care of. The one thing I would ask you to do, though, is use your actual email to sign up for it, because then I can find you. There's tens of thousands of users out there, but not too many of them have WCC addresses, so I'm going to locate you on that service and add you to the class.
They already have it, we're good.
Yeah, you already have it.
So we sign up that day over the weekend on our laptop or whatever. You don't have to wait on Monday or Tuesday.
No, if you want to start playing with LaTeX and see if you can figure out how to use it, there's a lot of examples online. You can Google it and
where it's Monday
To start writing? You know, you could also start writing it in a Word document or something and then cut and paste it into the system when you're ready.
Do that.
One last question. Does everybody know what I mean by an ASCII document as opposed to something like Word? ASCII is or some people just call it a text document. It's pure text. It doesn't have any formatting in it or anything. Like, have you ever used Notepad on your computer? The kind of files that Notepad uses are ASCII. It's the American Standard Code for Information Interchange. But that's literally, the characters are just the letters. There's no, oh, this is a sensory font with 12 points. There's no formatting of any kind. It's an A. Right? So that's the kind of file that you create and that you run the LaTeX program on in order to create your formatting stuff. You're working with a plain text file. If you're going to do something, you might as well use something like Notepad. If you want to do work ahead of time, do something like Notepad, put it in plain text.
No, I was just wondering if it was like, if I'm writing the paper, I'm thinking when I write the paper, I'm typing. But then it's me off the last text and then the
So you
video is showing.
can probably write most of what you do without needing to do anything special with LaTeX. So most of the stuff will be just plain text. Occasionally, you might want to throw in an equation or something that needs formatting, in which case then you need to learn the special stuff.
Oh, so I don't need to learn anything new before I start the paper.
Yeah, we can work it out on Monday. We'll just we'll import your stuff into that.
Think about this, maybe that's